cracking story, this one. So this is another one that Terry picked up on. M51. So there's a good history of M51 as a galaxy. It's a galaxy that's around about 28 million light years away. So not one of the ones that you can typically say naked eye. In the mid 1800s in Ireland, at the behest of a chap called Lord Ross, who was really into observational astronomy, he built a gigantic telescope known as Leviathan that Terry and I have both stood in. It's quite amazing. When we were invited to give a tour there, we've got a great photo of the two of us standing in the front of this behemoth, recreated behemoth of a telescope. And it was where some of the first observations of galactic structure took place. And some of the original drawings there in the house and museum. It's a fascinating place. If you ever get a chance to go over to Ireland, definitely go and visit it. It's wonderful. So this place where galactic structure was first seen has now been the first location where an extragalactic exoplanet has been detected. Now, you think about the complexity and the difficulty in this. What you're looking at is, even with the nearest star system to us, with Proxima Centauri, and we've now proved that there's exoplanets orbiting pretty much most stars. I mean, it's 1 in 10 from telescopes like Kepler, which has been in orbit, and looking at these transit events where what happens is a planet will pass in front of the star and the light from the star will dip due to the planet basically passing in front of it. So larger the planet, the bigger the dip, etc. If you've got multiple planets, you'll see multiple dips. So that's one method. The other method is using spectroscopy, where you're looking at spectral lines and you can see changes in the spectral lines and shifts in the spectral lines caused by the gravity of orbiting planets. So, interesting methods, both of them. But from an optical standpoint, even at the nearest star system, which is just over 4 light years away, recognizing that something, the Earth, for example, could be swallowed up by the sun a million times. So it's the sun, in terms of its mass, is a million times larger. So if you had a small planet the size of the Earth orbiting in front of the sun, and you were trying to look at that from 4 light years away. Now, don't forget, 4 light years, you've got 186,000 miles per second. There are 86,400 seconds in a day, 365-ish days in a year. And then times that by 4.3. And essentially, that's how many miles you're talking about to the nearest star. And these stars outshine and are far brighter than anything else in their vicinity, obviously, because planets don't have natural light of their own. They just use the reflected light from the star. So even detecting this, which was first done in the 1990s, and we've now got over 4,000 exoplanets in our own galaxy, is an incredibly difficult challenge, but one that even amateur astronomers are now able to do. From the back garden telescopes. If you've got a decent sized back garden telescope, you can take part and see these light curve dips because the quality of cameras, etc., is getting so good. So this detection, however, was using an X-ray or combination of X-ray telescopes. This was the Chandra telescope run by NASA and XMM Newton, which is run by the European Space Agency. And if you want to see one of those, XMM Newton, if you go to the Toulouse Space Centre in France, if you ever get a chance to go there, they've got a full-size model of the XMM Newton out in the grounds there. So it's a big telescope. Now, the thing about X-ray radiation is that it's at the kind of higher end of the frequency spectrum, so shorter wavelengths, etc. And technically, therefore, you should be able to get more precise observations. It's still incredibly complex, but what this team did, based at the Harvard-Smithsonian Center for Astrophysics Research, what they did was they pointed at M101, M104, M51, 3 relatively nearby galaxies, and they were looking for these dips, and they found one. So this planet is known as M51 ULS1b, snappy name as we know. Really, really remarkable discovery using this transiting method. It's hopefully going to open up observations of a plethora of extragalactic, or pan-galactic, but extragalactic exoplanets. And based upon what we've found with Kepler and the sheer number of exoplanets out there, the question then begs, again, it goes back to the fundamental question of, are we alone in the universe? And no, we're not. It'd be crazy to even think that we are. If you think that our galaxy has got approximately 250 billion to 400 billion stars, each one of those stars is capable of hosting, like our sun is, 8 planets that we know of. Right now. And then if you times that by 250 billion times 8, that's potentially just for our galaxy. And then you've got 250 to 400 billion known galaxies in the observable universe. So to think that we're alone and we're the only life form is just crazy. It's literally crazy talk. The interesting thing, as I keep coming back to this, is that even with Proxima Centauri and the Alpha Centauri Proxima Centauri system, the fastest spacecraft humankind has ever developed or designed would still take in excess of 4 to 8 thousand years to get there at the current speeds that we can travel at. So hopefully in the future we'll have hypervelocity, vehicles that can go possibly up to 1/10 the speed of light. That's been speculated for quite some time, using nuclear drive, nuclear propulsion, or even kind of solar sails, just gradually accelerating these spacecraft. And hopefully at one point we will be able to detect not only the exoplanets, which we are doing, but the really detailed observations of the atmospheres of these exoplanets. Because if we find an exoplanet in the Goldilocks zone, so that kind of region where it's not too hot like Venus and not too cold like Mars, where we are relative to our sun, orbiting another star system, and then we detect in the atmosphere of that evidence that potentially there could be life, from some organic, detection in the atmosphere of that planet. What do we do then? That's the big question, because that life could be very primitive. It could be just plant life. It could be, it could be something as advanced as a dolphin, but still not able to communicate with us in a method that we would understand. And you look at SETI and some of the radio observations that have been going on for many years, and I admire, people like Frank Drake, the Drake equation, working out the possibility of life, and so many people have worked on the SETI program, Seth Shostak, etc., for many, many years. But if you think about it, the entirety of human history, where we've been an intelligent, sentient species that could really think and perform calculations and do things, is maybe 10, 20,000 years. Our ability to transmit and receive radio only started around about 160 years ago, 170 years ago, and we've only had the transmitter capability in the last maybe 80 to 100 years to be able to reach out to these far-flung star systems. And then right now we're reducing our use of traditional analog radio, etc. So the whole thing of listening for radio waves, yeah, there could be something out there, but I think there's got to be a better way of detecting, potential life. But as a discovery, this is still amazing. Terry, you found this story. What are your thoughts on this?
Yeah, I think we need a slight caveat. They're only, what shall we say, 95% sure that this is a planet. There's no other thing that they can think of that would produce the particular dip in the X-ray emission. But the object, they reckon it's about the size of Saturn, but it's about 20 astronomical units, or 20 times the distance of the Earth from the Sun out in its orbit. So it's a very slow orbit, and it'll take about 70 years before it will come round again to do another occultation of the X-ray source. So you can't be really 100% sure until you get a complete orbit. So they're not totally sure, but there's certainly no other explanation available at the moment that matches the dip in the light curve. But as you say, that this is just absolutely fantastic to be able to detect another planet 28 million light years away. I mean, it's mind blowing, just mind blowing.
It really is, the mileage calculation. Yeah. As I said, it always, even if you look at things like New Horizons and the extreme velocities that was launched at, and the relatively short period of time it took to get out to Pluto, compared to the Voyagers, obviously, with their grand tour of the solar system back in the 70s and 80s, it's still somewhat depressing in many respects to realize just how vast space is.